In this problem, we want to expand 2x minus 3 to the third power using the binomial theorem. Now this is just a small example to demonstrate how the method works. Traditionally, it would be much easier to expand this by foiling or multiplying out each term. But this will help us see with a basic situation how to use the binomial theorem. The first step of the binomial theorem is to find your exponent, which in this case is 3, and to set up Pascal's triangle using that value. So Pascal's triangle says if your exponent is 0, your coefficient is 1. If your exponent is 1, your coefficients are 1 and 1. If your exponent is 2, your coefficients are 1, 2, and 1. Notice what just happened there. We always keep rewriting these two 1s on the outside, and then we combine the numbers that meet together by adding them. So notice we brought down the 1s again, and then 1 and 1 adds together to give us 2. Okay, let's try that again. So if your exponent is 3, you put your 1s on the outside, and now we combine these two numbers. 1 plus 2 gives us 3, and 2 plus 1 gives us 3 again. Now our exponent was 3, so we could stop there, but I'm going to show 4 just for a demonstration. Again, we place our 1s on the outside, and now we combine the numbers on the inside together again. 1 plus 3 gives us 4, 3 plus 3 gives us 6, 3 plus 1 gives us 4. Okay, now you may not understand what these numbers mean, and that's where they come in next. As I mentioned, they are the coefficients, meaning the coefficients of our answers. We're going to multiply each of these values to each term in the final polynomial that is our answer. So these numbers will come into play in just a moment. So to start this off, we're going to list these numbers out. So we are using this third row. Let me underline it here. So we're using this row here because our exponent is a 3. So we go to the exponent row of 3, and that says we need 1, 3, 3, 1. So 1, 3, 3, 1, and we want to leave a lot of space here because we're going to be putting in terms in between. And the way the binomial theorem works is you will take your first term, which is the 2x, and you will raise that to your exponent, which is 3. Then you will take your last term, which is negative 3, and you will raise that to 0. Then you will add that to 3 times, again, your two terms, 2x and negative 3. So I'm going to write these all out really quick. 2x and negative 3 will keep coming up. And we're adding all of these terms together. And now we just have to plug in the exponent values. So we have 3 and 0. And now we're going to take 1 from the first one and give it to the second until we run out of numbers to take. So that means we're going to have a 2 here and a 1 here. Notice 3, 0, we take 1 from the 3, that gives us 2. We add 1 to the 0, that gives us 1. And now we repeat. We'll take 1 from the 2, that gives us 1. We'll add 1 to the 1, that gives us 2. And then again, we will take 1 from the 1, that gives us 0, and we'll add 1 to the 2, that gives us 3. So simplifying this, we have 1 times 2x to the third times negative 3 to the 0. I'm going to do this in multiple steps to avoid confusion. 1 just goes away. Anything times 1 is itself. And negative 3 to the 0 is just 1. Anything except 0 to the 0 power is 1. So we end up with 1 times 2x to the third times 1, just to show the simplifying that happened here. Again, we have 3 times 2x squared times negative 3 to the first is negative 3, plus 3 times 2x to the first is just 2x. Oh, and I just want to make a correction here. This 2 should be on the outside. It's to the entire parentheses. I just copied it down wrong in the second step. So 2x to the first is just 2x. That first power goes away. Negative 3 to the second, negative 3 times negative 3 is positive 9. Plus 1 times 2x to the 0, well, anything to the 0 power except 0 we said is 1, times negative 3 to the third. Negative 3 times negative 3 is positive 9, times negative 3 again is negative 27. Okay, so we can keep simplifying this further. 1 and 1 being multiplied to this 2x to the third, like we said earlier, will just go away. So 2x to the third, we're going to distribute the exponent to each of their exponents. So we end up with 2 to the third times x to the third. Well, that's just 8x to the third plus, here we're going to multiply our 3 with our negative 3. That gives us negative 9 times 2x to the second. Well, 2 to the second, when we distribute our exponent, 2 to the second is 4. And x to the second is exactly that, x squared. Plus 3 times 2 times 9. That gives us 3 times 2 is 6, times 9 is 54, times x. And finally, 1 times negative 27 is just negative 27. So our last step to simplify this is just to multiply this negative 9 and 4, which we could have done earlier as well, but it's better to separate these to show all the work. So we have 8x cubed minus 36x squared when we multiply negative 9 and 4 plus 54x minus 27. And this is the completely simplified form of 2x minus 3 all to the third power.